All right, good morning. So now we're moving on to Chapter 7, and we're going to look at 7.1. The rest of our classes will be 7.1, 7.6, and then I think 7.4 or 5. I can't quite remember, but essentially there's 3 lessons left, and that's it for Math 10. Okay, so what did we just cover? Before this, I'm just going to shift over just to remember. We went over 6.1, which was slopes. That's when you draw a line. You need to calculate how quickly it goes up or down by finding out how much it rises divided by how much it runs. Okay, so that was our first one, and that's a very important thing. And it's represented by m, and there's an equation that you can use, which is y2 minus y1 over x2 minus x1 if you need to, just by choosing 2 points on the line. Okay, and when we did that, you notice that a line like that, a horizontal line, would have a slope of 0. This one here, that's going uphill when you walk left to right, would be a positive slope. One that would go like this, when you're walking left to right, you'd be walking downhill. That would be a negative slope. And then last of all, if we had a straight up and down line, that's one is called undefined, because it's straight up and down. Okay, so those were the 4 different cases. That was our first unit that we went into, and then we went to 6.2 or 6.4, I think it was. And then the 6.4 here went into slope intercept, which is the most common way to show a linear line in an equation, and that was our y equals mx plus b. And it's very easy to do when you have the slope and the y-intercept. So again, if you have a line here, you can draw your line. Say I just draw this one. So you would have to calculate what the slope is. Again, that's our rise over our run of this particular line. And whatever that slope is, you calculate it, you get a number, and you'd plug it in there for that m. And then your b value would be where it's crossing the y-axis. And say that looks like, say, 3. Then you would put your 3 in for that b value. And then this equation, with those 2 values plugged in, would represent this line here. Okay? And sometimes you would get a line and you'd have to make the equation, but sometimes you get the equation and you have to draw the line itself. So that was 6.4. And then our third lesson that we went into just last day was 6.5. And this was slope point form of the equation. I would say it's not quite as prevalent as this one here, but it's still useful. And sometimes you're not given the intercept value, or that dot, or it doesn't cross on an even number, so it's too hard to use this equation, and you need to find the slope, and you just use a point in the line, any point. It doesn't have to be the y-intercept. So here, this one was y minus y1 equals m bracket x minus x1 bracket. So that was our other equation that we use when we're not given a y-intercept. Okay, so what you do here is generally they say, let's say you're given this, and I'm going to put little ticks, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. I'm going to draw a line and say I have a point right here, and let's say we have another point right here. Okay, and then I draw my line. in this equation, you can see that it crosses the y-axis not on a nice number, not right on 1, not right on 0, somewhere in between. So we don't want to use this one. Okay, but we're given 2 points, one there and one there, so we can find our slope, and we can also find a point because we could just use one of these 2 points. Okay, so first you would find the slope, which we could use the equation up here to find slope because we're given 2 points. 1 point here, the second one is 1, 0, and then this one here is -3, +1. So those are my 2 points. I'm going to say this is my first point and this is my second point because this one's more to the left. So that's my x1 value, my y1 value, this is my x2 value, and my y2 value there. Okay, so if I want to use this equation, I can go y2 minus y1, or 0 minus 1 will give me -1, over x2 minus x1, which is 1, minus -3. Okay, and that is 1 plus 3, which is 4. So my slope is going to be -1 over 4 over here, and then, so let's write that, y minus y1 equals -1 over 4, x minus x1. And then last of all, we just have to plug in a number for y1 and x1. So our x1 is -3, and our y1 is 1. Okay, so we'd write y minus 1, it's always opposite the sign of what it is, so that's +1, so we are -1. And then it's a -1/4, and it would be x minus -3, which is x plus 3. Again, the opposite sign of what they show there. Okay, so that's the equation for this line in slope point form, rather than slope intercept, because intercept is not an easy one to find. And you could always convert this equation to slope intercept form if you needed to, just by doing algebra and solving for y. But I won't do that. So that there. Okay, so those were the last 3 lessons that we went over. And now we're going into Chapter 7, which is called Systems of Equations. But really what it is it's still linear or straight lines. But they're called linear systems because you have 2 of them and you have to solve where they cross. Okay, but today we're not going to be looking directly at the graphs. We're going to be looking at just developing systems of equations from word problems. Okay, and this is generally a really tough thing to understand or to wrap your head around, putting words into equations, but it's very useful because you could picture you'd have real life situations that you need to put into equations so that you could do some algebra and solve them. So here's I would say a more simple one. Create a linear, we change straight line system to model this situation. But right now we're not going to be looking at the lines themselves, we're just going to be making the equations. Okay. It says the perimeter of the Nunavut flag is 16 feet. Its length is 2 feet longer than its width. Okay, so here they don't tell you what its length is or what its width is. They just say that it's 2 feet longer than its width and its perimeter. So at the end of this whole unit, we'll be able to solve these and say what the length and what the width would be. But now we just want to write the equations. That's all we're doing today. So what is perimeter again? Perimeter is just the whole sides added up. Length plus width plus length plus width. Okay, so it's length plus width plus length plus width. There you go, I have an equation for it. I can simplify this though, because length and length are the same, width and width are the same. So I can go perimeter is 2 lengths plus 2 widths. So there is one equation for this flag here. Okay, and this equation represents this statement. The perimeter of a Nunavut flag is 16 feet. We just have to put the 16 in there because they say the perimeter is 16, so that P is 16, 2L plus 2W. Okay, which means my perimeter is going to be equal to 2 times my length, whatever that is, plus 2 times my width. Okay, so you could guess length and width are going to be less than 16, of course. And then for systems of equations, you always have two equations. So we have one here. We got to come up with another one. And that's where the other sentence comes in. Its length is 2 feet longer than its width. Okay, so generally when I go through these questions, it's length. All right, length is means the same thing as an equal sign. 2 feet longer than its width. 2 feet longer, which means added to its width. And there we go, we have two equations. If you notice, both equations just have an L and a W, an L and a W. Okay, so same variables are used, but they mean different things. So we just made a system of equations, system of linear equations. So we have one system there, one system there. Or I guess the whole thing would be a system. All right, and now let's go to B. It says Denise has determined that the flag is 5 feet long and 3 feet wide. So that would be a 5, that would be a 3, is what they're saying. Okay, so at the end, not of today, but of a different day, we'll be able to solve and figure out that it would be 5 and 3. But they said that someone else solved it for us, and they said it's 5 and 3. It says use our equations just to check that they're right, that this is a true statement. Okay, so we're going to verify that they're right. So we're going to take both equations, 1 and 2, and we're going to check these numbers to make sure that it works out. Okay, we're going to check out that the perimeter really is 16 for 5 foot long and 3 foot wide flag. Okay, so I'm going to write my equation that I have, 2L plus 2W. I'm going to plug in my values into this equation and just check that both sides are equal. So 2, my length is 5, 2, my width is 3. So if I plug this, 2 times 5 is 10, 2 times 3 is 6, 10 plus 6 is 16. So I put a little check mark there and say, yes, it is true that that the perimeter of this flag would be 16. Okay, so this verifies the perimeter is 16 for a 5 foot by 3 foot flag. Okay, so we verified that part. The only other part that we have to verify is the second one, which we say, is the length 2 feet longer than the width? Well, I can just look at that and see that, yeah, the length is 2 feet more than the width, right? 5 is 2 more than 3. So that one's pretty simple, but it's still smart to go through just the process. So length is 2 plus W, just copying down the equation that I had made. And then my length is 5, so I'm going to plug that in. 5 equals 2, and my width is 3, so I'm going to put that in bracket. And then we saw 2 plus 3 is 5, and then 5 is just 5. So that checks out. They became equal. Okay. So this here verifies that the length is 2 more than the width. So it turns out that both the equations are true, so that means that the flag must be that 5 foot by 3 foot. Okay, there's no other combination that could work that would answer both the perimeter of 16, and that would be 2 feet longer length than width. So that was the systems of equations. That was a type of question. Now we're going on to this next one, which is a specific type of question that you see quite often, and you're going to get more questions like this, but they're quite hard to understand, but soon enough you'll probably memorize how it goes. So this is definitely a type of question that you'll get, and a big flag about what type of question this is if it has a money value. These questions generally have money values. So it says create a linear system to model the equation. What it means is create two equations with the same two variables. So it says, in Calgary, a school raised $195 by collecting 3,000 items for recycling. It says the school received 5 cents for each pop can and 20 cents for each large plastic bottle. So you can bet they collected, out of those 3,000 items, some of them were plastic bottles and some of them were pop cans, so that they added up to 3,000. And then the $195 was if you took 5 cents for each of those pop cans and 20 cents for each of those plastic bottles, they added up to $195. Okay, so first of all, 3,000 items. I think the most simple equation that I can think of is we're going to go pop can, I'm going to put a C for that, and plastic bottle, I'm going to put a B for that, because those are our two items. Those are our two variables. We're not sure how many of each there are. Okay, so I'm going to make those two my variables. My equation number one that I would make is 3,000 items is equal to the number of cans plus the number of bottles. All right, so we have 3,000 equals C plus B is our equation.